So now the topic is DLVO theory. Now the topic is DLVO theory. So this graph is there. From this graph, what we can interpret, that is the major concept in this. So this is the potential energy, like positive and negative, and this is the interparticle distance. See, the distance between this particle is like this here. See, this is here one particle, here one particle, here another particle. The distance between the particle is very less or very close, and the distance between this particle and this particle here, and another one is the distance between this particle and this particle. So this represents the interparticle distance, and this represents the potential energy. So this is this line indicating the repulsion, and this line is there. This positive line indicating the repulsion. The repulsion is due to the electrostatic. What kind of repulsion it is? Electrostatic. Means in between the ions. Electrostatic repulsion. And attraction. See, attraction is due to the van der Waals forces. Attraction due to the van der Waals forces. Repulsion due to the electrostatic repulsion, and attraction line due to the van der Waals forces. And next, we have drawn another line. This is red line. This line. See this line. This line, it is derived upon the algebraic conversion or algebraic extraction from this positive and negative. Positive and negative means repulsion and attraction lines are extracted. Sorry, the net energy line, this middle line is extracted from this above and below two lines, from repulsion and attraction lines. This medial are inter-energy, net energy curve. This net energy curve is extracted from repulsion and attraction curve. So what this indicating? This peak indicating the stable, means there is a stable formation, means there is a stable colloidal dispersion formation. Stable colloidal dispersion. See, stable colloidal dispersion is formed here. See, I have represented this. The distance, and this is 3 to 4 angstrom. At 3 to 4 angstrom distance between the particles, attraction is equals to repulsion. Attraction is equals to repulsion. The particle exhibits the Brownian motion and leads to stabilization of that colloidal dispersion, and the zeta potential at that angstrom, means at that distance the zeta potential is 30 millivolt. What? How much? 30 millivolt zeta potential is present when the particle distance, the distance between the particle is 3 to 4 angstrom, then zeta potential is 30 millivolt, then there is a formation of stable colloidal dispersion, and the particles exhibit the Brownian motion here. See, at this distance the particle exhibits Brownian motion, where at the same time the attraction and repulsion are equal at 3 to 4 angstrom. This is very, very important. This peak is very, very important. So what will happen? At primary minimum means when the distance between the two particles, like this, the distance between the two particles is very, very close, then they will go like this, and there is what happened here means interpenetration of atomic orbitals. See, orbitals get penetrated, one atom orbital penetrated into another orbital, another atom orbital is penetrated into this. See, interatomic means interorbital penetration is happened at primary minimum. leads to the precipitation. Precipitation means how much force you can apply. There is no redispersion of these two particles at primary minimum, because there is a interorbital penetration. Orbital of one atom and orbital of another atom get penetrated, leads to formation of this kind precipitate. Due to the attraction, the forces are attraction only, primary minimum. Then what will be the secondary minimum? Secondary minimum also due to the attraction, aggregation of particles. Aggregation of particles. At what distance? Secondary minimum is at the distance between the two particles. The distance between the two particles is 1000 to 2000 angstrom. The distance between the two particles is 1000 to, the distance between these two particles is 1000 to 2000 angstrom. See, at 1000 to 2000 angstrom, secondary minimum, there is exhibition of secondary minimum. This is due to attraction, leads to aggregation of particles. The secondary minimum is used in control of flocculation. In control of flocculation. See, this majorly used in control of flocculation. Secondary minimum. Secondary minimum is majorly used in the control of flocculation. So here the more stable emulsion due to the Brownian motion and zeta potential also 30 millivolt. This here primary minimum attraction for the precipitation. This is not at all redispersible. This is not at all benefit to our colloidal dispersion. Yes, this may be beneficial because there is a flocculation. Just the particles are just like this. The particles are just like particles are present near. All the particles, three particles are just like are separated at different distance. Like just see, the particles are separated at a certain distance. The particles are separated at a distance, leads to the formation of floccules. Leads to the formation of floccules. Here, this is advantage. This is advantage. But primary minimum is due to there is no gap between the two particles. There is no gap. Leads to the precipitation. Leads to the precipitation. See, aggregation. How this aggregation will be there? This is the aggregation of particles. Here precipitation, there is a settling of particles at bottom. This is about precipitation. This is about aggregation. See, aggregation is useful, but precipitation is not at all useful. So this is the difference between secondary minimum, primary minimum, peak at 3 to 4 angstrom, how the distance between two particles, how it is. Then what the stable colloidal dispersion and zeta potential, that how the repulsion forces are created, how the attraction forces are created. All these things are explained by DLVO for lyophobic colloid, for the lyophobic colloid stability. For the stability of lyophobic colloid, the four scientists have proposed a theory. For the stability of lyophobic colloid, the four scientists have proposed a theory how the particle distance, upon increasing of distance, what is happening, what is going on, like this, all the reactions, all this kind of informations is going to be happened when the particle distance will increase, upon increasing of the particle distance. This is very, very, very important, DLVO theory.